right, so for our last learning objective, we're going to talk about the exponential distribution. Now, this is related to the Poisson distribution that we looked at in an earlier chapter. Remember the Poisson distribution, we looked at this with respect to the Starbucks company. Remember they were trying to figure out, the manager was trying to figure out how many customers would come by over a 5-day period. So the Poisson distribution is used for, number one, discrete variables as opposed to continuous, but it is also used to count the number of occurrences or determine the probability of a number of occurrences occurring. So the exponential distribution is used for, again, a continuous distribution, not discrete variables, but we're using it for measuring how much time has passed, how much time has elapsed, or even how much space has been encountered between occurrences. Now, the important thing to remember is that this is always non-negative, right? It always has to be a non-negative number. It can be 0, but it can't be negative. All right, so we're going to use, this is the Greek letter lambda, and lambda we're going to use as our rate parameter. So lambda is going to tell us the average time that passes between occurrences. So remember, our expected value, or our mu, our mean, is in this case, in the exponential distribution, going to be equal to the standard deviation, which is equal to 1 divided by lambda. So the mean is the average time between occurrences, whereas lambda, we can just rearrange this formula to say that lambda is equal to 1 divided by the mean, or 1 divided by the expected value. This is this rate parameter. It measures the number of occurrences that will occur over a unit of time. So we may measure how many customers come over an hour, or how many people come through the drive-through in an hour, or how many orders are placed in an hour, something of that nature. So again, the exponential distribution is based, primarily or entirely on the parameter that lambda is greater than 0. You can't have a negative rate of occurrences. So it can be 0, but it can't be negative. So here we can see our graph of our distribution. These are some different lambdas. Notice that the rate changes over time. And so it's always non-negative. You may get very, very close. It starts at 0, and then we can get down asymptote where it's very, very close to 0, but we can't go into those different quadrants of the graph where it's negative. Now in Excel, we can calculate the probability that a variable is less than something, or even the probability that a variable is greater than something by saying 1 minus. We can't, however, Excel doesn't have a way for us to calculate the variable, to find the variable of something, of the exponential distribution. So let's look at an example. Here we're looking at the time between email messages during a work hour. We're told that it is exponentially distributed and it's a mean of 25 minutes. I don't think I go 25 minutes without getting a work email, but maybe. So first of all, we need to calculate the rate parameter. We need to calculate lambda. So since we know the mean is 25, we can say lambda is 1 divided by 25, or 0.04. Okay, so that is our rate parameter that we can then use to calculate the probabilities. So here we're told, what is the probability that you do not get an email for more than an hour? So looking at our graph, we're looking at that green area. What is the probability that it is more than an hour? It's more than 60 minutes before we get an email. So in that case, we're calculating the probability that X is greater than 60. Well, remember in Excel, we're always calculating less than or equal to. So in this case, we've got to use that 1 minus sign. So we're going to enter our formula as the probability of X equals 60 as 1 minus AXPON dot distribution. And then our terms are X, what we're looking for, in this case 60, lambda, which we just calculated to be 0.04, and then 1 because it is cumulative. So let's jump over to Excel and practice this. So again, here I am in my Excel spreadsheet. I've just opened a new tab and I want to calculate the probability that x is greater than 60. So since I know Excel is always calculating the probability of less than or equal to, I'm going to say 1 minus, and then I'm going to go up here, type my statistical. I want the exponent.dist, and so x is 60. Lambda, remember we calculated that as being 0.4, and yes, I want it cumulative. All right, so we have approximately 9% probability that we will not get an email for more than an hour. So now we want to know, what is the probability that we will get an email within 10 minutes? So now we're looking at what is the probability that x is less than or equal to 10. So since it's less than or equal to, we don't have to use that 1 minus. We can just jump into Excel and enter our formula. So let's go do that now. All right, so here we are back in Excel. The probability that it's less than or equal to 10, I'm just going to type it in this time. So my x now is 10. My lambda, remember we calculated as 0.04, and I definitely want a cumulative. Again, just like with the normal distribution, if you were to enter a 0, it would calculate the height of the graph, but it wouldn't calculate the area underneath the graph. And so there is a 32.968, so approximately a 33% probability that we will get an email within 10 minutes. And that certainly sounds pretty reasonable from my perspective here.